Alright, so our second video today is section 7.3, double angle, half angle, and reduction formulas. And we are going to do the double angle formulas and the reduction formulas, and then after we're done with that, we will probably all agree that we could live without half angle formulas. We're going to skip those, but they are in this section of your book. So the first couple of formulas we want to do are double angle formulas. What to do if we have something like sine of 2 theta. And we want to get the obvious question out of the way, which is, can I just pull this 2 outside the sine? All right, is that a good formula to use? All right, and we're going to kind of spot check this with an angle that we know, just like last time. All right, so I'm going to pick theta to be something on the unit circle. 45, that would be easy. So we'll take sine of 2 times 45 degrees, and we'll ask if that is equal to 2 times sine of 45 degrees. All right, so over here on the left, this is going to be sine of 90 degrees, which we know is 1. And then over here, 2 times sine 45. I know that sine 45, if I find that on my unit circle, is square root of 2 over 2. So this is 2 times square root of 2 over 2. And the 2's will cancel out, and that gives me square root of 2. Okay, and 1 square root of 2, those are not equal to each other. All right, so the answer to my question, can I just pull the 2 outside of the sine? Nope, we cannot do that. All right, so to figure out what we can do, we're actually going to figure this out. I'm going to erase all of the stuff that we can't do. And I'm going to use that formula that we learned in the last section. I'm going to remind us of it, about sine of alpha plus beta. That was our addition formula. So that was sine alpha cosine beta plus cosine alpha sine beta. And that should be on your identity sheet on the back of your unit circle. Right? And I'm going to use that because sine 2 theta, I can actually think of that as sine of theta plus theta. That's the same thing. And so then I can just think of this theta as being alpha and this theta as being beta. So when the formula says alpha or beta, I'm going to replace it with a theta. So sine alpha, which is theta, cosine beta, which is theta, cosine alpha, sine beta, and I get this. All right, and then let's see, sine cosine and cosine sine, those are really the same thing. It doesn't matter what order we multiply things in. So this is actually equal to 2 times sine theta times cosine theta. All right, so you can't really pull the 2 outside of the sine. It kind of looks like that a little bit, but then you get this extra cosine bit hanging on the end of it. All right, so that's the next identity that we want to add to your identity list, that sine 2 theta is 2 times sine theta times cosine theta. All right, you can also pull the same kind of thing, cosine theta plus theta, and use the double angle formula, the addition formula from the last section on cosine, and you will get cosine 2 theta equals cosine squared theta minus sine squared theta. All right, now an interesting thing happens with the cosine 2 theta formula here, because if we remember back, if you look back on your list of identities, we had this identity that sine squared plus cosine squared was equal to 1. Sine squared theta plus cosine squared theta equals 1. And if I rearrange that identity a little bit, so if I solve it for cosine squared by subtracting sine squared theta from both sides, so if I subtract sine squared theta from both sides of this identity, then I get cosine squared theta equals 1 minus sine squared theta. Okay, so since that purple identity is always true, I can rearrange it, it's still always true, and I can replace this cosine squared theta with 1 minus sine squared theta from that identity in purple. And so then I have 1 minus sine squared theta minus sine squared theta, and it makes this identity also equal to 1 minus 2 sine squared theta. All right, so that's just an alternative version of the cosine 2 theta formula. So you can either use cosine squared minus sine squared or 1 minus 2 sine squared. All right, and you can also take that sine squared plus cosine squared formula and rearrange it, solve it for sine. If you do that, you'll get a third version of this formula, 2 cosine squared minus 1. All right, so depending upon, so these are actually all three the same formula. Okay, they do the same thing. They do the same job. And you pick the one that you want based on what you have, what information you have. If you only know sine, only know cosine, maybe you know both, you might choose one format of that identity or another. Okay, so we want to add all four of those onto our identity sheet, and then we'll just do a couple of examples using them. All right, so our first example asks us to find the exact value of sine 2 theta, cosine 2 theta, and tangent 2 theta. All right, and then they give us this theta angle. They give us theta in the triangle. So we're actually looking for the sine, cosine, and tangent of the angle that is twice as big as that. We don't have a triangle for the angle that is twice as big as that. We don't know what the side lengths would be, but we're going to be able to do this with our identities for sine 2 theta and cosine 2 theta. But the first thing that I'm going to do is come over to this triangle and figure out what the third side is. I'm just going to do a little bit of Pythagorean theorem. So let's see, I got the adjacent side plus the opposite side squared equals 5 squared. So I get a squared equals 21, or a is the root of 21. All right, so that is my adjacent side, square root 21. I'm probably going to need that, so we may as well get that out of the way. All right, so they want us to find sine 2 theta. So all I'm going to do is copy down that formula for sine 2 theta. Okay, we've already established we can't just find the sine of theta and then multiply it by 2. We have to use that formula 2 sine theta cosine theta. All right, and sine theta and cosine theta, those are things that we can easily figure out from our triangle. Okay, sine of theta is opposite over hypotenuse. Opposite is 2, so that's going to be 2 over 5. Cosine theta is adjacent over hypotenuse, our root 21 over 5. Right, those are multiplied together in the formula. And then the formula comes rigged with a 2. And then all we have to do is multiply straight across. Remember that 2 is really 2 over 1. So just multiply all three numerators. 2 times 2 times 21 will give me 4 root 21. 1 times 5 gives me 25. And that is sine of 2 theta. Whatever theta is, and you double it, you find the sine of it, you would get 4 root 21 over 25. All right. And we can do the same thing with cosine 2 theta. All right, now cosine 2 theta, you have 3 choices for your identity. You can use cosine squared theta minus sine squared theta. You can use 1 minus 2 sine squared, or 2 cosine squared minus 1, whichever one of those 3 that you choose. Let's see. I'm looking at above, let's see, when I found sine was equal to 2/5. That's prettier than cosine, so I'm going to pick the cosine double angle formula that is 1 minus 2 sine squared theta. Okay. And that's just because sine looks prettier than cosine in this particular problem. But it wouldn't matter which one you chose. You could use any of them. So remember that this notation actually means sine of theta squared. All right, and sine of theta squared, that we know is 2/5. Okay, we know that from the triangle. So 2/5. This problem says square it, multiply it by 2, and then subtract from 1. Okay, so just simplify order of operations. I've got 1 minus 2. Squaring this, I get 4/25. Next comes the multiplication, 2/1. So this 1 is just hanging out, minus 8/25. All right, and then common denominator. The 1 I'll write as 25/25 minus 8/25, and that gives me 17/25. All right. And again, that is exactly the same number that you would get if you used one of the other two versions of the cosine double angle formula. Okay. And then the last thing it asks us for is tangent of 2 theta. Now, there actually is a double angle formula for tangent, but I figure as long as we found sine and cosine of 2 theta, then we can just use the fact that tangent of any angle is equal to its sine over its cosine. So we're just going to say this is sine 2 theta over cosine 2 theta. Because we just found sine of 2 theta and cosine 2 theta. So I'm just going to take my answer for sine 2 theta, 4√21/25, and divide it for my answer that I got for cosine 2 theta, 17/25. And that's just a little keep change flip, right? So we say 4√21/25. Find the reciprocal, 25/17. All right, and then these 25s will cancel out. That leaves me with 4√21/17. So like I said, there is a formula for tangent 2 theta. You can look it up in your book if you want to use it instead. But you may as well just use sine over cosine. All right. Okay, so that's the first thing we'll use our double angle formulas for. Next example, simplifying expressions that kind of resemble our double angle formula. So if you look at your identity sheet, you notice that this kind of resembles the double angle formula for sine. So if I kind of remind us what that looks like, our sine 2 theta formula is 2 sine theta cosine theta. Right? And we have, this is like sine theta cosine theta. Our theta just happens to be equal to pi/12. And I can't evaluate that directly on my unit circle because pi/12 is not on my unit circle. I'd have to use a calculator. But if I want an exact value, I've got to think about this in terms of this identity. Okay, so I don't have 2 sine theta cosine theta. I have 6 sine theta cosine theta. So I'm going to rewrite that as 3 times 2 times sine pi/12 cosine pi/12. Okay, that's the same expression, 3 times 2 is equal to 6. But now this part looks exactly like my sine 2 theta formula, except instead of theta, I've got pi/12. All right, so this 3 is just going to hang out there. And then 2 sine pi/12 cosine pi/12 by my identity over there in purple is equal to sine 2 theta, which is pi/12. All right, and then that just simplifies. I can reduce the 2 and the 12 to make this 3 sine pi/6. And because it ended up in the double angle formula, now I've got an angle that I can evaluate on the unit circle. I can look at my unit circle and see that sine of pi over 6 is 1/2. And 3 times 1/2 is 3/2, or 1.5. Okay. So noticing that things look like these double angle formulas can simplify things a little bit. All right, next we have these power reducing formulas. These power reducing formulas are just a variation on a theme from the cosine double angle formulas. Okay, so we had the cosine double angle formulas, like cosine 2 theta. If you just look on your identity sheet, you'll see this. We had 1 minus 2 sine squared theta. And we also had cosine 2 theta equals 2 cosine squared theta minus 1. Okay. So all they have done is rearranged those and solved those for the sine squared and the cosine squared in the formula, and that's where they get these power reducing formulas. Okay, so the power reducing formulas, this one and this one, are what you want to add to your identity sheet. All right, and the reason that we need these, there are calculus problems that you can't solve if you have an expression like sine squared or cosine squared or with a high exponent, particularly an even exponent, but you can solve them if these things are rewritten in terms of the first power of cosine. So that's going to be the problem we're going to do. We're going to rewrite something with an even exponent on it in terms of the first power of cosine. So they give us sine to the fourth of x, and they want us to rewrite that in terms of the first power of cosine. All right, and the formulas that we just got on the previous slide are for sine squared and cosine squared. I have sine to the fourth, so I'm going to have to rewrite sine to the fourth as sine squared times sine squared. You could also write that as sine squared in a big set of brackets, squared, either way. Okay, but I have a formula for a sine squared of, it's written as sine squared theta over here, so I'm going to think of this as sine squared x. Oh, man. Just erased my stuff. Let me rewrite that. Sine to the fourth. If you've been patient to get to this point in the video, you can be patient a little bit longer. All right, so sine squared x, sine squared x. All right, so I'm going to use this formula for sine squared x. All right, so sine squared x by my formula, I'm going to put this in a big set of brackets, is 1 minus cosine 2x over 2. And I'll use it again for the second sine squared, 1 minus cosine 2x over 2. Okay, so because these are identities that I've got over on the right-hand side, these two expressions are exactly equal to each other, right? And it kind of looks like I have succeeded. They wanted us to write this in terms of the first power of cosine. So at first glance, it kind of looks like I did that. I've got cosine to the first and cosine to the first. All right, but if I actually multiply those fractions together, like I multiply across the top and across the bottom, I'm multiplying 1 minus cosine 2x times 1 minus cosine 2x. And across the bottom, you get a 4. Okay, but that is a FOIL. That is, I would have to multiply this out. Okay, my first, outer, inner, last on top. And when I do that, when I multiply the last, I'm going to get cosine times cosine. That's actually going to give me a cosine squared. Okay, which is not, unfortunately, in terms of the first power of cosine. All right, so I'm going to FOIL out the top. My first term is giving me 1. My outer term gives me a minus cosine 2x. Inner gives me also a minus cosine 2x. And then that red swoop that I've got up there, that's going to give me negative times negative is a positive cosine squared 2x. And that's just hanging out over 4. Okay, so everything is in terms of the first power of cosine. I can, in a minute, I'm going to combine these two. Those are just the same thing. We'll make that minus 2 cosine 2x. All right, but this thing is not in terms of the first power of cosine. I've got a cosine squared. So I'm going to use my cosine squared formula on this one. Okay, so what do I do with cosine squared of 2x? Okay, well, look at this formula. Whatever is inside the cosine squared gets doubled over on the right-hand side. Okay, so if this is 2x, then inside the formula will be 4x. Whatever is inside the cosine squared gets doubled over on the right. So if that was cosine squared of 5x, then in the right-hand side of the formula it would be 10x. Okay, so I'm going to replace this red box over here with 1 plus cosine 4x over 2. All right, so let's do those two things. I'm going to get 1. I'm going to combine those two under the bracket there, minus 2 cosine 2x plus, I'm going to put that fraction, and then that's all going to be over 4. So that fraction is 1 plus cosine 4x over 2. All right, and technically that is all in terms of the first power of cosine, but you never want to leave a fraction looking like this. I mean, when you do this problem in calculus, you're going to be trying to do some crazy calculus stuff on it. You're not going to want it to look like what it looks like right now. It's too messy. All right, so we're going to simplify that with a little trick. I am going to multiply, just like finding a common denominator, I'm going to multiply this fraction by 2 over 2. Okay, so on the bottom it's just going to be 8. Here I'm going to have to distribute this 2. I'm going to distribute to this fraction here. I'm going to distribute to the middle term, and I'm going to distribute a 2 to the front. Okay, so let's see if I can fit this over here. All right, so I'm going to distribute a 2 to the 1 up top, so it's going to give me 2. I'm going to distribute a 2 in the middle, so I'll have minus 4 cosine 2x. And then when I multiply that red box, that whole fraction by 2, it's just going to wipe out that denominator, that 2 on the bottom, and it's just going to leave me with 1 plus cosine 4x. Okay, it's going to completely, this 2, let's see if I can highlight that. This 2 and this 2 cancel out when I distribute it there. Okay, I still had to distribute it to the other two parts. Okay. And then that is all hanging out over 4 times 2. Have to multiply on the bottom as well. 8. All right, and we are almost done. The only thing that I have left to do, I've got to combine this 2 and the 1 into a 3. That's all we have left to do. Okay, so I'm going to make that a 3 minus 4 cosine 2x plus cosine 4x over 8. Okay, and that is written in terms of the first power of cosine. And I know it is hard to look at that fraction and believe that possibly that could be simpler to deal with than sine to the 4th, but I guarantee when you get into calculus and you're trying to work the problem on sine to the 4th, that fraction with the 8 in the bottom looks a whole lot more pleasant. All right, but that process is probably nobody's favorite process. That takes a long time. Okay, all right, so that's all we're going to do with the power reducing formulas is to rewrite things like sine to the 4th, cosine to the 4th, or maybe like a sine squared times a cosine squared using those power reducing formulas. All right, that is it, and I will see you when we get back. Have a good weekend.